this video, we're going to find powers of complex numbers in polar form. It says given z equals 2 root 2 plus 2 root 2 I, find z cubed using De Moivre's theorem. Now, De Moivre's theorem takes a complex number that's in polar form and takes it to the power of n, and that gives you r to the n cis n theta. And I wrote this piece out here because I wanted to show you that this is not any different than when we were multiplying and finding products just a couple of objectives earlier. All we're doing here is saying, okay, R1 times R2 times R3, but R is all the same for those three. And then cis theta 1 plus theta 2 plus theta 3. We added the angles, we multiplied the radiuses. The only difference here is that we have the same radius and the same theta. But our value here for z is not in polar form, so we need to get it in polar form. So we're going to say that r is equal to the absolute value of z, which we know the absolute value of c is the root of a squared plus b squared. And a here would be 2 root 2, so I have the root of 2 root 2 squared plus b, which would be 2 root 2 squared. And so I can say that when I square this piece, that's 4 times 2, root of 4 times 2 plus 4 times 2. So I get 8 plus 8, so that's the root of 16, which gives me 4. So I can say that my r is 4 here. Now, how do I find the angle? Because I need the angle. I know r now, I need the angle. Well, what I can do is I can draw this triangle. And remember, this is a complex plane where the imaginary values are on the y-axis and the real values are on the x-axis. So this would be 2 root 2 coming from the real piece, and this 2 root 2 would come from the imaginary piece. So if I draw this line here, this was my r value, which is 4, but I want to find that angle, theta. Well, I can do tangent theta is equal to 2 root 2 over 2 root 2, which is equal to 1. When does tangent theta equal 1? That happens at pi over 4. So now that I have those two things, I can now write what z is in polar form. So z is going to equal 4 cis of pi over 4, which pi over 4 is 45 degrees. So I'm going to write that as 45 degrees. So then I can take this and use De Moivre's formula and say that 4, well, let's go z cubed is equal to 4 cis 45 degrees cubed, which would equal 4 cubed cis 3 times 45 degrees, which I end up with 4 cubed being 64 cis, and 45 times 3, let's see, I think 135, and it is. And so we end up with this in polar form, but they're actually wanting this in complex form. So I gotta now take that and rewrite this into basically the imaginary form. So to do that, I'm gonna say that 64, we're gonna expand this, cosine 135 plus I sine 135. And remember, I'm trying to get this into a plus bi form. So cosine of 135 would be negative root 2 over 2. And sine 135 would be positive root 2 over 2. And this is times 64. So if I distribute that, this will give me 64 times this piece is going to be negative 64 root 2 over 2 plus I 64 root 2 over 2. Simplified there, I get negative 32 root 2, and then plus I, and this would be 32 root 2. And that would be our final solution right there.